Huh? Have heard about TensorFlow? Using R? Who's using R here? Have used R? Okay. Cafe, Keras. Anyone who have used Keras here? Okay, cool. So one of the tools that allows you to build your own TensorFlow, or your own machine learning models is TensorFlow. Okay, it's one of the libraries that you can actually use. But what makes TensorFlow unique is you can build your deep learning models at the same point in time. You can build your regular machine learning algorithms on TensorFlow. So TensorFlow is the #1 repository in machine learning category on GitHub. It's also the #1 library and framework in 2018 Stack Overflow Developer Survey. Okay, so this was released way back in 2016. So it's an internal tool that they have been using in Google, and they find a way to open source it so that community can contribute to its development. And developers such as you are can use the tool itself and the library itself to enable you, to empower you to build your own machine learning models. So as of this time, there's around 17.5 million downloads, around 39,000 commits. There's around 1.6K contributors. If you would want to also contribute to the work, you're free to do so. And there's around 11,500 issues responded. So there's a lot. It's a global community. So these are the a lot of points in which TensorFlow is downloaded. Probably that's me in the Philippines. So if you would want, you can just go to github.com/TensorFlow to download the library itself. So TensorFlow, it contains APIs. It has also a set of platforms and languages that you can leverage on. And it also allows you, it provides you with several tools and pipelines to enable you to publish your machine learning models very, very fast. So it is supported by different types of platforms. So it can run on GPUs, it can run on CPUs. You can also do your training if you have a large bulk of data on the cloud itself. So you can use Google Cloud Platform Services, Cloud ML Engine to do your training on the cloud if your machine isn't able to, isn't powerful enough to train your data. And you can deploy TensorFlow models and integrate it in various platforms. So it works on iOS, it can work with Android, it can work with IoT, Raspberry Pi, if you like. So you can build one model, and you can actually publish it and use it on different types of platforms, may it either be on mobile or web. So how to install? You just need to go visit the website. So it's tensorflow.org and then install. So all of the installation instructions are there to follow. But if you don't have the machine capabilities, one of the recommended tools that you can also use is Collaboratory. Okay? If you have your own Gmail account with you, you can just go search Collaboratory and you can build machine learning models, or you can make your own tutorials there and leverage the tutorials on TensorFlow and use Collaboratory to do all of your trainings. So I've been talking about training. Okay, I think as mentioned, you do a lot of effort into training your machine learning models, right? So in TensorFlow, they have been using these two libraries, or two main libraries, to help you or create your own models. So first is what we call as TF-Keras, and they have at the same time their packaged models as part of estimators. So as part of the training process, you need to use like a TF data component to put all of your data there. In the previous versions of TensorFlow, you can bring your data like in CSV format or in Excel format and feed it to the dictionary and feed it to the machine learning engine itself in TensorFlow. But now it's recommended that you use TF data. I'll discuss why. So why is it needed? Because if you happen to perform distribution, meaning you want to do training on different types of machines because your data is too big, TensorFlow allows you and automatically performs distribution strategy for you, so it can actually perform parallel training depending on the devices or depending on the engine that you want to use on. So you can train on CPUs, you can train in multiple GPUs and TPUs. So in previous use cases of TensorFlow, you will be the one handling like splitting all your data, parallelization of training. But now, if your data is on TF, that data, TensorFlow will handle all of those complexities for you. So the main output of training, so you do all of this in TensorFlow, and in TensorFlow you can actually produce what they call as saved model. Okay, so this is the main data that your TensorFlow library produces for you. Okay, so it includes all of the rules of the machine learning and the deep neural network algorithms there. Okay, so it's more like this is the output now. Okay, from all of the hyperparameter tuning. Okay, all of the machine learning models and data that I have been used for training. So it's a saved model itself. So once you have the saved model, you can now move into the deployment. Okay, this is where inferencing happens. So you can use TF serving. Okay, if you're just deploying it as an API, TF serving is a much more better approach. You can use TensorFlow Lite if you will be deploying it on your mobile devices. You can also use TensorFlow.js. There will be a talk after me about TensorFlow.js. And then you can also I think they haven't pushed this yet, that your saved model can also be put on TensorFlow Hub. Okay, I'll be discussing all of these deployment options for you so that you can understand deeper the importance of the entire TensorFlow ecosystem. I'll be giving the slide, so you can skip taking pictures. I'll be sending it, okay? Don't worry. So just a very straightforward Keras. So prior to Keras, I was using a different, it's a low-level API for TensorFlow, but they have changed it so it's much more faster for you to train machine learning on the fly. So this is a very, very short line of code that allows you to use an existing model. Again, there are different varieties of entry point. As ML developer, you can start with using APIs, right? But if the APIs won't satisfy your cloud APIs, doesn't satisfy your needs, you can move into leveraging existing models. And all of those models are available for you to use in TensorFlow Hub. So this is an example of pulling an existing TensorFlow Hub model and reusing that model for your project, okay? So all you need to do is to perform what we call as transfer learning, so that this model would be trained on your data, okay? So if that doesn't come workable for you, this is the time that you need to develop your own model, okay? So again, there are different types and levels that you can play around with machine learning. You can start very, very easy, consume cloud APIs, and then next, use existing APIs and perform transfer learning to fit your needs. And the last one, which is a much more complicated one, is building your own models. Okay, so different types and different levels. So one of the things that they have incorporated in TensorFlow is Keras. It's a high-level neural network and makes it easy for you to create and put into code your neural networks. And what's important also is you can actually train it with different varieties of data sets. So they have already included data sets inside Keras so that you can play around with all of these data sets. So one of the data sets that you can use is the Fashion MNIST. So Fashion MNIST, it's a compilation of images which helps you or which provides you data of what are different types of clothing. Since it's a sandal, there's also a pullover and so on, and you can use this data to perform image classification. Okay, so if that's the task that you would want to accomplish. So this is just simple code in TensorFlow using Keras itself. So there's a 2-layer there. Okay, you have your last layer as a softmax. Okay. And then you can also perform what we call as eager execution. So in the previous versions of TensorFlow, so it's more like a C++ or a C coding language. But since probably most of the libraries are in Python now, so eager execution allows you to code it in a Pythonic way. Okay, so you just need to activate eager execution. So ever since its inception, so TensorFlow has broadened dramatically in terms of various tools it has developed. They have been developing a lot of tools very, very fast. Like I think this year they have probably launched different variations of TensorFlow, like around 6 to 7 times this year. And then they will be releasing 2.0 at the end of the year. Okay. So this TensorFlow Lite, this is TensorFlow JS. Okay, you can train on the cloud. There's also TensorFlow Hub. So a lot of these tools will be the one to help you like publish your machine learning models and reuse existing machine learning models. And it's also part of a larger ecosystem. So you can use like Google Cloud Platform. You can integrate it in TensorFlow. I think if your main cloud platform is in Azure or in AWS, you can still publish all of your TensorFlow models there. There's no issue regardless of which cloud platforms you will be using, because as TensorFlow, it's a widely used and commonly used library. Therefore, all of those major cloud platforms support TensorFlow. So just to give a brief, as mentioned, one of the tools that you can use is TensorFlow Lite. So TensorFlow Lite, it's a way for you to publish your machine learning model from TensorFlow into mobile devices. So why on-device machine learning is important? So again, it depends on the use cases of your product or of your project that you will be developing. Okay, it's possible that most of your users are using mobile. Okay, they're not on the web, but they use mobile phone devices. Or you have an existing mobile app, and you would want to put some machine learning capabilities in there. So what TensorFlow Lite provides is that when you use, sometimes you need to have a lower latency. It's not all the time that you would want to connect to the internet itself, because it eats up a lot of battery. And in some of the cases, you would want to have your personal data of your users to stay on the device itself. You don't want to push it, okay, to the cloud. And you can leverage different types of sensor data, okay, especially if you're building IoT applications or IoT devices. So these are some of the benefits into using TensorFlow Lite, because it handles all of these issues, such as memory constraints, lower energy usage, and compute power. So what happens is that, again, the main idea is still you need to learn TensorFlow and how to use it. But once you have already built the saved model that we discussed a while ago, all you need to do is to convert that saved model into a TensorFlow Lite model. Okay. So what happens is that it shrinks it, okay, tries to optimize the computations behind it, make it small, make it very, very fast. You can perform inferencing very, very fast. And you can now easily integrate it into your Android application, iOS app, and Linux, such as Raspberry Pi. Okay? So, but a challenge right now for TensorFlow Lite is that during the conversion, you need to always check if the accuracy is still the same or not. Because sometimes you automatically change some of the weights or change some of the rules there, which makes the inferencing a little bit lesser accuracy compared to the TensorFlow model. So you need to always observe all of those some issues when you do the conversion for TF Lite. So TF Lite size is around 400 KB and only supports several operators. It supports all of the mathematical operations in TensorFlow. So you just only probably support around 60 operators in TensorFlow Lite. So you need to also observe what are the supported operators. You don't have any issues when you perform the conversion itself. Another tool that you can use is TensorFlow JS. I will not dig down deeper into this because the next speaker will be talking about this further. But it is a way for you to actually develop machine learning with JavaScript. So you can use and run existing models, such as the one that you have built on TensorFlow, and leverage it on the web itself. So currently, I don't know if this changed. In terms of comparison, again, so most of you need to start TensorFlow, right? So you can perform model training in TensorFlow, you can do model inferencing in TensorFlow, okay? In TensorFlow Lite, there's no support for training on device yet. meaning you do the training outside the device. You can convert existing TensorFlow to TF-Lite. Okay, that's what happens. So there's no support yet that you do training on the fly on a device. And you can perform inferencing, yes. I think for the Tweet, TensorFlow and TensorFlow.js, you can do inferencing, okay, on those platforms, either be on mobile or web. And for TensorFlow.js, you can actually, yes, do model training. I think it's more of a transfer learning in the TensorFlow.js. And you can also like convert your TensorFlow model into a TensorFlow.js model. So another tool which is relatively useful, especially for those who don't want to build their own machine learning model and leverage on state-of-the-art machine learning models which is out there, is TensorFlow Hub. So TF Hub is a repository of pre-trained model components packaged for one-line reuse. So imagine you don't need to build your own machine learning models. All you need to do is to use existing models. So all of these models are in TensorFlow Hub. Okay, I think the future work for TF Hub is you can also publish your own machine learning models on the TF Hub, and yeah, so that people can also like reuse your machine learning models that you have pushed and put into the TF Hub. So it's an easiest way to share and use best approaches for your task. So you have lots of different models there for image classification, for natural language processing. So all of those models are already state-of-the-art. You can just download them as a one-line code in TensorFlow, and then you can use those models directly. So this is an example of like how to use an existing machine learning or TensorFlow Hub model. So you can just load the model, call the hub, call the module function, and just access the link to that specific TensorFlow Hub, and then you can easily like use that TensorFlow Hub model directly to your code. It's very straightforward. So another tool that allows you to publish and handles the complexity of the entire machine learning procedure is TensorFlow Extended. Most of the time, people think that ML code is just the only thing that you need to think when you are immersed, when you are into machine learning itself. But it has different types of complexities. Okay, so in addition to the actual ML code itself, is this different types of sections. Okay, so ML code is just only the smallest chunk. Okay, out of all the other things that you need to consider when you want to create your own entire machine learning pipeline. So you have several data collection would take a lot of your time, okay, because data collection would definitely help you build a much more better machine learning model. You have data verification there. You need to have tools to analyze all of your data. You need to perform feature extraction, and then you have several machine learning resource management. How do you train it? Okay, where do you train it? Okay, so all of this are the things that you need to consider, not only the machine learning code. And one of the tools that allows you to address this problem is what they call TensorFlow Extended. So TF Extended is the one who handles the entire data pipeline for you, starting from data ingestion up until from analyzing this data. And then you can actually use several tools embedded in TensorFlow Extended to perform data transformation, model evaluation and validation, and serving that, okay, as an API, an accessible machine learning model to several of the tools that you would be developing. So you have several libraries that you can leverage on in TensorFlow Extended. So first one is TensorFlow Transform. So TensorFlow Transform is a way for you to actually like, okay, do feature extraction and handle data transformation for your data set, because sometimes if you have new data, one of the main challenges is that you missed doing the same data transformation that you did from your training data. Okay, so that would have an impact on how the data would be analyzed in your machine learning model, right? So data transformation or data TensorFlow Transform itself holds several algorithms or several ways for you to manage and transform your data, so that if there's new data coming in, it would be the same transformation based on the transformation that you made for your training data. So you have the estimator and Keras model hidden inside TensorFlow, and then you have TensorFlow model analysis, which is a visualization tool that allows you to observe, okay, is your model performing good or not? And then you have, and then the last part is TensorFlow serving, is where you now publish your TensorFlow models or your machine learning models for them to access. Okay, so it handles the entire data pipeline for you. So it's called TensorFlow Extended. So yeah, so there's a lot of tools available that allows you to build an end-to-end platform in TensorFlow. And what are the other resources that you might want to leverage on? So you can use and go visit tensorflow.org, and a lot of resources are there from all of the tools and all of the APIs and technologies that I mentioned a while ago. And then you have github.com/tensorflow, which just contains all of the repositories. If you would want to download all of those, or you would want to contribute, you can go to GitHub. And then there are several machine learning resources for you to use if you would want to have a bit better understanding as to what is machine learning, what is deep learning. So you have Udacity courses for there available for deep learning. I think there's a machine learning crash course also in Google. So you just need to go to Google, search for machine learning crash course.